good afternoon, good morning. My name is Bram de Bruin and I am the host for today for this Ubiqu webinar. It's a deep dive into the QTSP and wallet technology. For those who are for the first time in a webinar from Ubiqu, we also had other webinars about the authentic sources, what they need to do regarding eIDAS 2.0. We also had a webinar about the QTSP ecosystem, how to become a QTSP. There's more webinars on an abstract level, and this is a technical deep dive. And that's also the main reason why we invited Boris, CEO of Ubiqu, for this webinar. Boris, maybe you can introduce yourself.
Yes, thank you very much, Bram. Everybody, welcome. I'm Boris Goranov. I'm the CEO and founder of Ubiqu, and I'm happy to take you in the wonderful world of QTSPs and remote secure elements and wallet technology today. The agenda for today is first a bit of setting the scene on the eIDAS 1 and 2. Then we're going to dive into architecture reference framework, and then we're going to look at remote secure elements and QTSPs. But before we start, I just want to basically massage the brain a bit and ask you to calculate how much seconds there are in 2 weeks. I'll just give you a couple of seconds to calculate that. But you can also cheat a bit and see the number on the Ubiqu logo. It's 1,200,000 seconds in 2 weeks. So let's dive into eIDAS 1.0 and 2.0.
And Boris, before you continue, maybe
Yes.
It's also handy to say that we have a chat environment in where you can ask all your questions and also give the answers about the seconds in 2 weeks. That was a very good question. Don't hesitate to ask questions because it's quite technical, and if you don't understand something, just shout out. Happy to help.
Thank you very much, Bram. So if we zoom out a bit and if we look at the history of identity and data, what we started out is with doing wired internet and connections. And so we have telephones and point-to-point radio, etc., etc. And then later we started also doing mobile, and during that same time we started doing cloud and centralization. So what I want to introduce to you as a concept is that to look at the wallet, as we're going to talk today, not as a device, but as a data pipe. It's in the same way as we're exchanging data wired, mobile, and then as through the wallet. And that has consequences if you look at it through that lens. So if we go to the past again, when we have a connection, a direct connection, our security model is based on the fact that we have connected two organizations or two applications. And what we see there is that if we have that connection, if the amount of organization of nodes increase, the amount of interfaces increases as well. And that means that it starts to get really complex really quickly because it scales quadratically. Our security model there is what we're used to think about is how do we secure the connection using PKI, secure customer authentication, or trusted layer connections. Now, because of the spaghetti and the amounts of connections that are needed, we started to think as a society, as professionals, how can we solve this better? And what we started to do is centralization and federalization. If you have a central node where we have each connection to connect to, that means that I don't have to do each connection between all the nodes, but I can have a single centralized federated connection. And this is the state of the art currently. And so what is important to understand is it's centralization, it's identity and access management, and on the central node you can do governance. And if we take that to the extreme where we have the centralization from the endpoint to the application, then we call it zero trust. So if we look at this approach, we can look at it from a bit of a different way and say on the left hand, we have all the data sources that are connected to a central node to all the data consumers, the relying parties. And what we see is that the data sources, the issuers of the data, in this model, there are not specific requirements on how they supply the data, etc. But the problem is that because of the centralization, once a relying party has access to the federation, to the ecosystem, they actually have access to all the data. They can basically the whole database of the issuer. So that means that you need to have stringent requirements on which relying party are allowed to access your ecosystem. So that means that you don't have an open ecosystem, but a closed ecosystem. And then for every domain, so healthcare, government, creates their own federation ecosystem or you create a specific ecosystem for a specific data exchange. For instance, in the Netherlands, for mortgages, there's a special exchange for exchanging mortgages. The government has their own data exchange for government data internally. And then it really starts to become complex if you need to have users engaged in. That means that for each federated network, you need to give a user his own authentication means and authorization. So this is basically, because of this, you see that a lot of IT projects, when it becomes sufficiently large, have large delays or actually fail. One of the examples here in the Netherlands was the electronic patient dossier in the past. So what does this mean? With eIDAS 2.0, with the introduction of a wallet, the wallet becomes the node. What this then means is that you solve the interdependence of the issuers and the relying party, that they need to know each other and that they need to be part of an ecosystem together, because eIDAS 2 becomes a generic ecosystem where the issuers and the verifiers exchange data, exchange information through the wallet, through the wallet of the user. This is actually a profound change, because where we are used to that relying party connects to the system and then requests data and has access to the data, with the wallet, the user needs to be involved. What that means is that an issuer needs to be able to service the wallet of the user. So now the user goes to, for instance, the tax office to get his an income statement. So for the tax office now, it's really simple. They need to identify the user, and then they can deliver to the user, to his wallet, his income statement. So now the user has the income statement in his wallet. And then the user himself can then take his income statement and deliver that to his bank, for instance, because they need it. What is important to note here is that the scope of the data exchange is just one user, one data point that is transported by the wallet, by the user himself. What is also noteworthy is that the bank doesn't directly interact with the tax office. So they don't need interfaces, they don't need to connect to each other, and they don't need to have a contractual relationship, because the user goes to the bank, to the tax office, and collects his own data and then distributes his own data to the bank. What is funny is this model is actually the model we were using or are still using when we're using paper. I request from the tax office a paper tax declaration, income declaration, that will, for instance, be sent to my home, and then I give it to the bank, for instance, also via mail. So that means is that in the past, when we started digitizing, we rely on the connection between the applications for the trust. I know that I connected to that organization, and because I connected to that organization, I received data from them, and that's why I trust that information. Because this model is complex and doesn't scale, we start to centralize the interconnection between organizations. So that means that I interconnect to the centralized system and I trust the data because it comes from the federated network. But that means that I have access to all the data and to centralization, and that introduces friction because not all relying parties can be easily part of the data exchange. Now, with the wallet, we are decoupling the issuers from the verifiers. So that means that I myself start using to transport my data, and that means that the scope of the data exchange is one. But now we get new capabilities that previously we didn't have. So the first thing is, because I have my wallet, on my wallet, I want also to be able to recover my wallet. And if I'm able to recover my wallet, I can recover my accounts. I have on my wallet, I can keep track which data I got from which organizations and with whom I shared the data. So I have my own personal transparency log. That's why it's also so important to have recovery, because I want to recover my own transparency log. Then when I'm collecting the data, the organization that is servicing my data, they have legally, it's really transparent, because I am requesting my own data that they are giving to me. And then when I give the data to another organization, I myself am the person that is distributing the data, and I'm giving consent for processing when I give the data to the organization. And now, but what is also important is the organizations are not sharing data directly. So that means that something new needs to happen. We need to protect the data itself, because it's going through me, so that the relying party receives, for instance, the income statement from the tax office, but now they need to know that the data actually came from the tax office. So that means the provenance of the data needs to be assured with digital signatures. And now another question arises. If I have data that I want to distribute to the user, do I want to have control who is allowed to read the data? So do I want to do some kind of audience management? So this is a bit of setting the scene. We have one, we're now moving to eIDAS 2, where we're starting to use the wallet as a transport means of data from issuers to relying parties. The EU has created an architecture reference framework so that we have a nice overview, so that we can make sure that we are all talking about the same thing. And what I'm going to cover here is what it means to service a wallet from the different providers and actors in the ecosystem. But I'm not going to go into the governance framework, but we're going to focus on the different actors that are interacting with the wallet. So we're going to start with the certificates, and the access certificates basically give every entity within the ecosystem a digital identity through an access certificate. And then we're going to focus on the wallet itself, the PID providers that are issuing an identity to a wallet, the attribute providers that are, for instance, tax office that's providing an income statement, or a university that's providing a diploma. And we're going to look at qualified electronic signatures and how that relates to each other. And we're going to end in the later chapter with the secure storage of the wallet and the devices. So when you look at the eIDAS, there are, in essence, three things need to be in place to have a secure and compliant ecosystem. So the first trust anchor is that I need a secure wallet. And the secure wallet means is that the user has control over the wallet, and he has stored his keys under his sole control in a secure element. The second thing on my trust anchor is I have my identity is verified on a high assurance level, and that identity is issued by the government as a PID into my wallet, so that the rest of the ecosystem can trust it. That's my second trust anchor. And then the third trust anchor is that we have qualified trust service providers that are servicing wallets, so that users can then collect their own information from those QTSPs, from those authentic sources, and then distribute it themselves to relying parties. So if we look at the certificate authority, What does the certificate authority actually do when you issue a certificate? I always start with this is because a lot of people are already familiar with PKI and certificates, so that's also good in setting the scene. So what happens is that in PKI, you always have two authorities. You have the registration authority that's responsible for checking and registering the identity of users or organization. And then we have a certificate authority that manages the life cycle of the digital certificates after receiving approval of the RA and then issuing the certificate to the organization. Now, within the architecture reference framework, what is important is the access certificates are used so that the wallet can recognize issuers that the wallet trusts, and the wallet can recognize relying parties so that the user always knows that from whom he's getting the data and to whom the user is distributing his data. Now, what does a registration authority do? So the first thing what the registration authority does is it verifies the identity of the subject. It's either a person or organization. And then after verifying the identity of the subject and his role, the registration authority checks if the subject is storing their keys in a compliant and secure manner, so that you know that the private key that's associated with the certificate cannot be lost by that subject. And then the registration authority makes records of this. Then the registration authorities request certification authority to issue a certificate, and the certification authority will make records of that, publish a status of the certificate for if it's revoked, and then deliver the certificate to the subject. Now, once all the parties in the ecosystem have their identity established, we can now start building the trust anchors for the ecosystem. So the first thing what the user needs to do is he needs to download a wallet from a wallet issuer. And the wallet issuer will then check if the wallet, the quality of the wallet, that it's not hacked and that it's compliant and on a secure device. Once that is checked, the wallet issuer needs to check if the wallet is connected to a certified secure cryptographic storage, a secure element, and check if the key that is being certified for that wallet is actually stored in certified hardware. And if that's the case, the wallet registration, the wallet issuer will make records of that to prove that has done. Then go to the issuing authority to issue a wallet unit attestation, keep records of that, keep a status of that if something happens that we can revoke the wallet, and then deliver the wallet unit attestation to the wallet. Now, once the user has an activated and valid and secure wallet, we can now start, he can now use his wallet to go to the government, to the personal identity data issuer, to get his digital identity issued to the wallet. At a minimum, the PIT provider will establish the identity of the user and then will check if it's a wallet that is certified for that member state, for that PIT, that it's allowed to issue a PIT to that wallet. Then make records of all the checks and then allow for the issuing of the PIT. It will check in the database if the user is actually a citizen of the country, and if that's the case, it will issue a PIT, keep a status of the issued PIT, and deliver the PIT to the wallet. Now, once the user has a secure identity and a secure wallet, he can now go to all the other actors called qualified electronic stations, attribute issuers. And then what does the QEA do? They basically check the PIT issued by the government, check the wallet issued by the wallet issuer, possibly collect other attributes, make records of that, go to the issuing authority, check in the database of the authentic source if the attributes verify. So if I have, for instance, if this is a driver's license, if I actually have a driver's license, make a record of that, and then issue my driver's license into my wallet. Now, and I can then do that with the tax office for my income statement, or with the university for my diploma. Now, the last thing what I can do is once I have a wallet and an identity, I can use my wallet and an identity to do a qualified electronic signature. How does that work? So using my PID and my wallet, I can prove to the provider of qualified electronic signature that who I am and that I want to sign a document. Now, the qualified electronic signature will look for my approval that I actually want to sign the document. So that means that we need the authorization of the subject for signing the document. And once that authorization is approved, the document will be signed and I can deliver a signed document. So what we see is that all the different cycles every time repeat. So I have an onboarding first by an actual identity onboarding by the government, and they make that reusable by issuing a PID. And now with the PID in my wallet, and the PID issuer has also checked the wallet, of course, so it's a secure wallet. So now I know that I have a secure wallet and secure issuer, and I can start showing my identity digitally online. And with the digital identity, I can start collecting information from authentic sources or from data sources from issuers and collect them in my wallet. And those organizations have a high assurance from my PID that I'm the correct person and they can service me with my own data. Now, with my wallet filled to the brink with verifiable credentials by the issuers, I can now start going around and delivering that data to relying parties. So what does that actually mean for wallets and secure elements? So if you look at passports, because basically what we are doing here is we are replicating a physical passport on our mobile phone. The key characteristic of a passport is a secure chip, a secure element. And what that means is that from the architecture reference framework, an EU digital wallet needs a secure cryptographic component to store those keys to get the same level of assurance as a passport. What we also see is that an EU digital wallet is not just the cryptographic key material, of course. It also has the interface to the mobile, to the issuers, to the verifiers. It has a user interface. There are a lot of important components that are all critical to the success. But today we're going to focus on the secure element. Now, why do we need a secure element? What is interesting to realize is that if you have a processor that is processing code and doing calculations and processing logic, one of the things is, and this is a bit of pseudocode, is suppose the processor is trying to check if the PIN you entered is the correct PIN to do a calculation, for instance, to calculate a digital signature. Now, suppose I'm a sophisticated hacker, and what I will do is I will have control over the voltage of the processor. So that means that I'll let the processor, the computer, run at the lowest voltage possible. And then when I detect that it's checking if the PIN is correct, I will reduce the system voltage a bit. So, and the trick here is that I am reducing it a bit that the processor doesn't reset, but it just gets a bit confused. And what that will mean is that the result of the calculation will be arbitrary, will be random. Now, if the pseudocode is if the PIN enter is correct, I set a value, the PIN check value now will be not false because I just entered I'm trying to hack it and I don't know the PIN, but it will be set to a random value. Now, suppose that if I do that and I need 1 second for every try, then what will happen is that the question is how, if I need 1 million tries to get a correct answer so that the processor will do what I like, and in this case, sign, how long will it take me to hack the system? And of course, the answer is that it will take 1 million seconds is approximately 2 weeks. But this is if it is really sophisticated programmed. Normally, if the ping check says if false is 0, that means that if it's other than 0, I only need one try to hack this system. And what is interesting is that only actual processors that have special protection against these types of sophisticated hacks are called secure elements. And they are called secure elements because precisely they have security against these kinds of sophisticated attacks. And normal processors don't have these kinds of protections. So that means that it's almost trivial to hack them with these kinds of attack methodology. Another kind of attack that is really known is that you don't manipulate the voltage themselves, but you just listen. And that's a side channel. That's called side channel attack. You listen to what the processor is doing, and then using basically data science, you can calculate what the processor is doing, and then, for instance, figure out what the private key is. Then, so if we then look for mobile phones that are currently in the market from Apple, Google, Samsung, or Android and iOS, what we see is that currently there is no phones on the market that are sold that have secure elements that are certified correctly, that are under the control of the user. So what that means is, I'll explain a bit later. So if we go back to the architecture reference framework, and the latest version is 2.2, the architecture reference framework says that, okay, for a secure element of a wallet, there are 4 options. You either have a remote HSM option, a local option, and a secure SIM option. So, or a identity card. So the first option is the classical identity card option. You have an identity card from the government, and then you use your identity card that's specially provisioned to work with the wallet. And then every time you want to use the wallet, you have to tap your identity card. The second option is that we use the native secure storage of cryptographic keys on the platforms of Apple and Google. And the other option that's available is that we can use the SIM cards from the telco, either the embedded version or the classical version. And then the last option is that we use a remote secure element that is external to the mobile phone, which Ubiqu is providing. Now, if we compare these solutions, so the classical smart card identity card is basically proven technology. It's 30 years old. There are many different compliant and certified solutions available from IDEMIA, from Thales, from Entrust. The solution is scalable. It's inclusive. A citizen doesn't need anything specific. They can just use it. But if you lose your card, you also lose your keys. It's not user-friendly because you need to have the card with you and you need to tap it every time you want to use your wallet. And because it's a physical card, you cannot activate it remote unattended. There's always a delay because it needs to be produced, and then you need an appointment to get it, etc., etc. Now, as I mentioned before, currently there are no mobile phones in the market that have eIDAS high compliant secure storage. It's actually even worse. The secure elements that are available are not built in the right way. They are not under the control of the user. They're under the control of the platform. Now, of course, Apple or Google could phone IDEMIA tomorrow and then order 1 billion secure elements, and then the iPhone 27 could have a compliant and secure chip on there and be compliant and secure. But it will take a couple of years, maybe even a decade, to have sufficient mobile phones in the field to have a sound ecosystem. And of course, it's not inclusive because citizens need brand new mobile phones in order to use a digital identity on their mobile. And you still have the problem that if you lose the phone, you lose the keys, but it is user-friendly and it's super scalable. More or less the same applies to the SIM cards, but for the SIM cards, it's even a bit more complex because they too are not certified. They too will need to be replaced, but with normal SIM cards, you can replace the SIM cards. So that is, but on the other hand, the ecosystem is way more complex because now all the now mobile network operators need to play the game and need to want to provision this. So if one telco doesn't play along, that means that their customers cannot work as well. And also with the new trend where we have embedded SIMs, then we have again the problem of the mobile network of the device manufacturers that you need new devices. And still, if you lose a SIM card, you lose the keys, but it's also user-friendly. And once you have swapped all the SIM cards, then of course you can remotely activate it. Now, one problem with both the device and the SIM card is that it's actual physical hardware on the mobile phone. What that means is that if there is a vulnerability in the secure element themselves, and usually it takes a couple of years to get one, to find one, but once there is one, that means that you need to swap out all the secure element. This, for instance, happens to Estonia a couple of years ago, where they needed to change 730,000 SIM cards to maintain compliance. Now, what we as Ubiqu have done is we have developed a remote solution that is compliant and scalable because it works, and inclusive because it works with existing mobile phones. And while we are innovating, we innovated a bit further, and we also have solved recovery at scale. And of course, it's user-friendly and remote unattended. Now, one column I didn't add, which is also noteworthy, is that when you're using the secure element of the platform, you're also creating a how do you call it? A dependency on the platform providers such as Google and Apple. And from a sovereignty point of view, that might also not be the most optimal way forward. So this analysis has been done by Germany in public. So I can, if you want, I can later send you the links so that you can verify basically the logic of this approach and this analysis. So why does a normal HSM or a cloud HSM not work as a remote storage for a mobile phone? Because normal HSMs and cloud HSMs are not built to be under the control of a mobile phone remotely. And thus, using such a solution only achieves eIDAS substantial. What is needed is you need a direct connection from the mobile phone into the HSM so that the user achieves sole control over the keys. And that means that basically the remote secure element acts as a local secure element for the user. And that way you can have an eIDAS high compliant solution. And what we have done as Ubiqu is we have basically innovated there. So in the HSM, every user gets its own micro remote secure element. So that means that we have a scalable solution where every wallet can have thousands of verifiable credentials, unlimited, without limitations, with high availability, all baked in. Now, we've talked about wallets, we have talked about secure elements. Now we go, and we started, of course, with the issuers that needs to, as the PIT issuer or the wallet united station issuer, they all need to become a QTSP. And what we at Ubiqu have done is we have created a QTSP platform so that we can help issuers become QTSP at scale. So what does it actually mean to become a QTSP? To become an issuer that issues verifiable data that can be trusted. To put it really bluntly, it's basically 1,500 line items in an Excel where the organization needs to demonstrate compliance. But on an eIDAS 2 compliance, that doesn't mean like people are used to demonstrate compliance, that you read the compliance requirements and have made documentation and interpretation for that, but you also need to demonstrate effectiveness for each and every line item. And that is a bit harder, and then you get audited every year and certified. And then with that certification, you go to your local regulator and then you submit your certification, and then the regulator will put you on the EU trust list so that the ecosystem can have confidence in you as a QTSP. So what we have done, so what our QTSP platform actually does is, what we have done is we have taken the infrastructure and automated that, and an operational environment and automated that, and a DevOps environment, the CI/CD, and automated that, and made a pre-compliant, pre-certified QTSP platform. So that means that the issuer has his audit burden of being a QTSP completely isolated from his normal services and applications. And we are able to do that because of our remote secure element, where we can give an identity to a user, but also to an application. We can, and with our automation, we have done 90% of the work so that the QTSP organization can focus on the generic compliance requirements, being they need a TSP management, they need an auditor, they need a compliance officer, they need a supplier manager, and they need an internal audit. And of course, they need to really understand their business and their risk and their organization and what being a QTSP means. But we as Ubiqu have pre-certified everything. So that means that they do not have to take care of the cryptography, collection of evidence, business continuity, disaster recovery, audit, identity access management, and access control. What that means is that you can actually become a QTSP in 3 months instead of the normal 2 to 3 years that it will take. So instead of having a high-risk project that takes 2 to 3 years, and if you make a couple of mistakes, maybe 4 to 5 years, and will cost millions of euros, we can de-risk you completely in your implementation. And what does that mean? So first is integration in our QTSP platform. Second thing is preparing your organization to become a QTSP and with their processes and aligning that with our processes. Then we need to complete the certification documentation tailored with the Ubiqu pre-certified solutions. And then, of course, the auditors needs to come by and actually do the audit on you as a QTSP. But the good thing is, because we are pre-certified for our components as part certifications, that doesn't need to be checked again by the auditors. Of course, they can always come by and do their extra checks if they want to, but there is no risk in that for you. So this was all the thing what I wanted to share with you, and I'm happy to answer any questions that there might be.
Thank you very much, Boris. I received a few questions also via the private chat. So let's start with the ones in the chat that you can see as well. The first question is, how is offline action in wallets working with remote HSM?
Yes. So the remote HSM, you have a PID and attributes that work online only. But what you can do is you have a high assurance, eIDAS high compliant online credential, and then using that high assurance online credential, you can go to the issuer and get short-term credentials issued to the mobile phone for offline use. So that means that your credential will be marked that it's for offline use, and then the private keys are stored on the local secure element. So you can basically trade high assurance with availability, but you can increase the assurance of the offline credentials by making them really short-lived. And that means that you only need them if you are actually offline. And then, of course, if you're a relying party that needs high assurance credentials, then the easiest solution is to just make sure that there's a Wi-Fi access point available for the mobile phone.
Thank you, Boris. Another question from Adam, and that's, would this solution also be suitable for businesses and or organizations that utilize digital seals for legal entities rather than wallets held by natural persons?
Yes, I focused on natural persons wallets because this is the most far conceptually from the architecture reference framework. But the remote secure element solution is also usable for legal person wallets and European business wallets. And actually, if you look at when we're using the remote secure element for the issuers, we're actually using it already in that mode, where you have an organization or an application that takes control of the cryptographic keys of that organization, but that is then under control of officers of that organization with their personal wallets.
Thanks for answering, Boris. If you have more questions, please ask them in the chat. I have also a few questions in the private chat. The first one is, I have a question about differences between QEEA and credentials. If I understand, QEEA are certificate-based and credentials are tokens. Are those technologies different and they propose is different? Is it possible to use credentials as QEEA or not? And I have put the question also in the Teams chat, Boris, for you.
Oh, yeah. So the credential is, or verifiable credential is basically the generic terms, like we have cows, and then we have animals, and credentials are the generic terms, and qualified electronic attributes are specific credentials issued by a issuer. Then there are different types of credentials. So that you can have a PIT as a credential, you can have a wallet unit attestation as a credential, you can have a diploma as a credential, and then each credential can have each issued credential can have different formats. So for instance, your mobile driver's licenses might be using the mobile driver's licenses ISO standard as a format for the credential. And then your PIT provider might be using the W3C standardization on SD-JOT for the credential formatting.
And Boris, there's also a follow-up questions I shared in the Teams chat. Maybe you can read it yourself because it also refers to the UK wallet.
So let me just check it. Question about there is a supervised issue whether the supervisor nobody knows. Follow-up. For a qualified electronic issuer, it is a QTS which is a supervised issuer. In case of credentials, please correct me if I'm wrong, it may be whatever entity supervised by nobody who knows. Now, so the idea is that if you are qualified, you are always a supervised entity. And then the wallet providers can either allow or disallow or issuing of non-qualified credentials into the wallets. So what that means is that if you are a qualified issuer of a credential, that means you're a PIT, wallet unit attestation, or a qualified electronic attribute, attestation of attributes, or a PUB EAA, that means that you are supervised, that you are on a trust list. And so that means that the relying party knows that from whom the verified credential came from. Now, if you are a non-qualified issuer, that means that the relying party needs to figure out how they are going to configure the trust. So that means that they manually need to configure, okay, these electronic attribute issuer, I am expecting to be provided by the user for this use case. So that means I, as a user, if I want to give you a non-qualified attribute, I need to go to the attribute issuer, and then the wallet needs to have a way to basically recognize that issuer and then deliver the verifiable credential to the relying party. But now the relying party really has to manually configure it for their ecosystem, the trust, so that they can really recognize the issuer of that.
Okay, thank you, Boris. I see one question from Oliver coming in. Is the HSM decentral or part of the DDoS security shield? And is this a Ubiqu service or an open topic?
So there are a couple of layers to this question. So the first answer is that the HSMs are always sovereign and under control basically of either the government or the wallet issuer. Then the Ubiqu service is the interconnection between the mobile phone and the HSMs. There's an orchestration layer in between to manage all the messages. That is part of eIDAS Shield. And there are many options on how you want to deploy that. In the basic option, we deliver that as a service, and part of that service, there's a eIDAS protection. But if you want to make your own arrangements or have it, then it's absolutely possible as well.
Okay, a lot of also deep tech questions I have seen. So that means that the story resonates, Boris. If there are no questions anymore, we will heading towards the end of this webinar. So maybe, Boris, you can show the final slide of this deck. And if there are no questions anymore, or maybe you still have a few questions, don't hesitate to contact Boris. I will put his email also in the chat to make sure you can approach him. And after summer, we also have a new webinar on the QTSP, how to become a QTSP, with more in-depth insights also from organizations that want to become a QTSP, and they will explain their journey. And we also have someone who can explain more on the business side of things. So thanks again for listening and watching, and have a great day and a great weekend ahead. Thank you very much.
Thank you very much, all. Have a nice weekend. Bye-bye.